Hello everyone. Welcome to the 5th episode of Debugging TV Frames program. You can type your questions during this episode. If I can't answer particular questions now, I then post answers on the website debugging.tv. During this episode, I'll improvise again and show you various techniques, commands, and provide explanations. So I also quickly discuss some topics, such as on this list, we would see software breakpoints, software breakpoint implementation, hardware breakpoints. I show you debug registers, and finally the command that I invented today for advertisements. I also demonstrate you the usage of some commands that are shown on this slide. So we debug today test Windows error reporting application. So I already have WinDBG running. It's 64-bit application, and I have WinDBG 64-bit. So, and I attach it to this process invasively. And what I do next, I open log file. I think the path is Debugging TV. Then I fix symbols. And also I add symbol path for test Windows error reporting symbols. And this should be this path. Then I reload. Then because this current thread is a debugger thread, you see some kind of a breakpoint you see on stack trace, so I switch to our main thread, application thread. We can see stack trace. So this thread is doing ordinary message loop. So another command that I want to show is X. It shows all available symbols for this module. So, and then I use wildcard to dump all of this, including MFC classes, C and C++ runtime. So, and then, I search, I test if there is, for example, about the constructor, about DLG. The child class of cdialog. So yes, there is one constructor. So remember, its address. So what we do now, we disassemble this function. You can use this command or disassemble the whole function UF. So what we see, this function assembly language code and binary code, and then what we do, we put breakpoint, software breakpoint on this function, and we see it's on the list. And what we do now, we put software breakpoints, and I show you in a second how they are implemented. They are implemented by placing int3 instruction, so that when code runs, it encounters that instruction in 3 and generates a breakpoint exception. So if we disassemble the function, the beginning of that function now, we wouldn't see any changes, because this debugger presents us the original view of code. But if we have another instance of WinDBG debugger and we attach to the same process, but now non-invasively, just to inspect its state, what we do sim fix, then we add path, just in case, use this one, then do reload, and then we copy this command and run it inside the second copy of debugger. What we see, we also see nothing, but after we put the breakpoint, if we run our application and disassemble again, we see that debugger put instruction at the beginning of this function in 3. So compare this with this. So what we do now, actually what we see here, debugger is running, and if we want to switch to this error reporting, we see we don't see, so it seems to be Han. So this is because if we switch to another application, we would see that the suspend count is 2. Because despite the fact that this program is running, another debugger suspended threads as well. So what we do, we quit this debugger, and then we go back. We actually see that we can switch to this application again, because there is only one debugger, and it allows this application to run. So what we do now, we do breaking, and we use another command, bp-cmds. It shows us breakpoints. What we do now, we clear this breakpoint 0, and then try to see there are no breakpoints anymore. Breakpoint list is 0. And I show you now another breakpoint command variant. This time we try hardware breakpoints. So this is another command, break on access. Whenever we try to execute code the first byte from this address, this hardware breakpoint will be triggered. So let's check now the list of commands. So we see this hardware breakpoint was set to trigger at this address, and we can try BL command now. So it's more informative. And what we see, if we try to disassemble we see the code is normal, and moreover, for example, if we go and try to attach to this process using another copy of debugger non-invasively, and try to disassemble this function, we see it's normal again. This is because the address of breakpoint is held in a hardware register. You are familiar with R command that shows registers, but you can also specify mask. For example, if you put 20 in hexadecimal, you would see debug registers, and you see this debug register contains exactly the same address that's for this breakpoint. So what we can do now, we quit, and then quit the second copy, detach the second copy of debugger, and then we switch and try to trigger that breakpoint. So we try to launch about dialog box, and we immediately got this breakpoint hit. So let's check a suspend count is 1. It's okay, because there's no second copy, second debugger copy. And what we do now, and you also notice that there is only one thread. There are no debugger threads, because there's no need to put there's no need to break into the process to put a breakpoint instruction to do remote breaking. So we see. So what we do now, we clear this breakpoint, and then we do go, and then we see continuation of about dialog box, but then we break in, and we have to switch to our thread, and then we try to see debug registers, and we see this register was cleared. So this is all I wanted to show. So I wanted to show you the difference between software and hardware breakpoints. So on this slide you would see the original debugger view and the view from another debugger that shows that interrupt 3 instruction was placed to trigger breakpoint. And also hardware breakpoints are implemented by placing breakpoint address into one of debug registers. For example, here is DR0. So I promised to talk about another instruction that I invented. Its name is ban add. It's advertisement. So in December, I provide advanced Windows memory dump analysis training. There are a few places left, and in January I repeat the 3rd time accelerated Windows memory dump analysis training. And you can always see training schedule, the current training schedule. Just visit dumpanalysis.com to see the current training schedule. So just I check if there are any questions. There are some questions. For example, The first question is, what's the log file you opened? I just opened the log file. It's just to save all commands and their output, so I could later post this log file on debugging.tv. So all the output. It is useful to have log files, especially if you have very long command output. So there is another question about how can you save breakpoints. Okay, I'll try to answer that offline and post on debugging.tv. So there is another question about first hardware debug register showed address of function to break on. How did it know that it was to break on executing code at that address? And this is because I placed the command BA did that. Of course, you can probably use if you are writing in assembly language and you have privileges, so you can probably write your own code to place to change debug registers. Oh, I see. That's the debugger. I use the E for execution, and about difference between E and read and write access, I'll elaborate on this during the next sixth episode. I'm going to improvise and play with read and write breakpoints, and so I could be able to answer your question fully. So seems to be after I finished presenting symbols, so now I start the whole series of episodes devoted to setting breakpoints. So thank you for watching this episode. So please later check out the slides and recorded video from debugging.tv. So the next episode is scheduled for 16th of December because of training sessions next week. But I will talk about breakpoints again, about read and write access and a few other things. Thank you very much for attending.